G'day guys. This is one of these quintessential couples problems. It involves two couples, an active couple and a reactive couple. And you're going to see through the course these sorts of classic problems appear. What will change will be what the bracket is. It might be a flagpole hanging off a wall, it might be a light hanging off a post. In this case, what we have some sort of bracket hanging off the wall with a pot plant on the other side. Now the key element in this situation is that screw there. Now that screw is doing two things. So if you think about this in terms of equilibrium, something the force is vertical, we've got a weight force which is straight down here. We have to have some force to balance that, equal in magnitude and opposite in sense. So we've got 20 newtons straight down. Therefore, we must have a 20 newton vertical force at the wall. Why, you may ask? Well, without that 20 newton force at the wall, it would slide down the wall. And that's the only place that it's anchored to anything firm. So it has to have a 20 newton force. So, if we consider a 20 newton force going vertically there, and a 20 newton force vertically down there, what we have is a downwards force here, and an upwards force here, equal in magnitude but opposite in sense. That means we have something that constitutes a couple. So that couple will be going clockwise and we're trying to rotate this bracket off the wall. We therefore need a couple that opposes that. That's the reactive couple. Now how do we get that? Well, if this bracket rotates off the wall, that screw is going to try and pull out. So there must be a force that goes to the left. But as that bracket tries to fall off the wall, the base of the bracket will push in to the wall. So therefore, there's got to be a reaction going the opposite way. Now, if we were to break it up, here's our diagram, here's our free body diagram. So this is spelling out what I've just explained. 20 newton force down there, a 20 newton vertical reaction so that we have vertical force equilibrium. Now, if we sum forces vertical, we can see they're in balance. But we don't have moment equilibrium. This thing wants to rotate off the wall and that couple is creating a clockwise rotation, or trying to. So what we now have is the anti-clockwise couple which balances it. So the tension in the screw is going back that way, and then we have a reaction at the wall as well. And these constitute the anti-clockwise couple that is the reaction. So anti-clockwise couple equals clockwise couple. We've got T, the tension in the screw, times 0.1, which is the distance between them, and we've got 20 times by 0.4. So that means the tension in the screw is going to be 80 newtons. But that's not the total reactive force in the screw, because remember the screw is doing two things. It's providing a tension force that way, and it's also providing that vertical shear force that stops it sliding down the wall. So we need to add those together. 80 newtons horizontal, 20 newtons vertical. And that gives us a total force of 82.46 and 14.04 degrees at that direction. This sort of problem will come up time and time again because essentially what it is a classic example of couples. And you'll notice from the video I shared a little while ago, which I showed the bracket mounted on the wall for the cupboard area over near the canteen, it's exactly the same principle. The bracket is mounted to the wall, it's cantilevered out. And any sort of system where we have an object cantilevered out is going to tend to create a situation just like that.